name's Chris, and this is my Hello World video for sharing some of the projects I've been working on. I've been inspired by some of the developer and maker YouTubers I follow to try to create my own video and share some of the projects that I'm working on. This first one will be a short one just to kind of get a feel for how I want to start putting together these videos and to get some practice in video editing because that is a whole new world for me. So I'm going to show how I use Fusion 360 and 3D printing to design enclosures and part mounts for some of the projects I'm working on. So, and hopefully this will turn into a larger video series as me documenting the steps I'm taking to become a jack of all trades. So I'm doing this because I like sharing what I'm learning, and this is a good way of doing it. It also is me trying to help give a leg up to people who are getting into either programming or 3D modeling or 3D printing or electronics or all the different areas that I'm trying to break into now at one level or another. So hopefully some of the stuff that I share will help other people get into it if they're interested. And then I think that one of the other big purposes is I really like showing off stuff that I'm proud of, and a lot of the stuff that I'm learning, even though in some cases it's very entry level, it's really cool being able to make this stuff, and I'm proud and want to show it off. So today in this video, I wanted to dive into creating stuff like this. So I have a project that I'm building at work where I'm using an Adafruit trinket and a NeoPixel ring to create an enclosure for for a resin dome that one of my coworkers made. So she came up with these really cool domes, and I immediately saw it and put a light under it and said I want to build a case for this. So there's so there's a lot of really cool. There's a lot of information that I learned along the way to creating this kind of stuff. So let's dive in. I'll show you what I learned. The first thing that I'll do whenever I'm designing a mount for Adafruit parts is I'll go to the product pages. Adafruit is fantastic about providing all the information about the boards that they're using, including the exact sizing and measurement for each of the pieces. So I can flip back over to Fusion. I'm bringing in a model by the Ruiz brothers for the NeoPixel ring, and then a model for the trinket with the JST connector that I mocked up really quick. So I'll insert both of these into my current design, and then once they're in, I'll go ahead and position them real roughly just to make sure that everything is on the plane that I plan on working on so I can start sketching stuff out. So once these are placed, we'll rotate things around and then hide it all and start sketching it out. So the first thing I'm going to do is sketch the base for the ring. Sometimes I'll go by the model measurements, but in this particular case, I'm going to take the inch measurements and provided by Adafruit and use those. Fusion's really good about converting inches into millimeters and vice versa, so I can put the actual inch measurements in even though I'm using millimeters. So I'll pull the ring up specifically so I can I'll center it with the part that I sketched out, so that as I'm drawing this stuff out, the pegs should line up pretty flush with the model itself. So I'll go through and sketch out, create a new sketch and draw out the inner diameter of the ring. So this is the path that I'm going to put the pegs across, and we can see now that it matches up with the interior of the ring. So I'll hop in here and draw a circle for the pressure peg. So I put in just an arbitrary value, but for the initial diameter size, but now I'll go through and move that out to a parameter. So moving it out here to a parameter means that later I'll be able to go through and adjust the size of the peg without having to actually go through and edit the original sketch. It becomes really easy whenever you're doing parametric design like this to make adjustments as you find things need to be adjusted once you print out the actual part. So just going through here to show that I can adjust the size of the pegs as needed. So now that I've drawn the first peg, I want all the pegs going around it to be the exact same size. So I'll do a pattern across the circle. I'll make 4 different pegs so that they get placed out evenly. And we could see that the pegs are not nailed down just yet, and that's because they haven't actually been attached to something. So I'm going to draw out a construction line that I can use to align the pegs to the rest of the circle. And I have to draw it out again so that I can nail that line down to the rest of the circle. So we got that line, and then we can see the line's not nailed down, so I'll make sure that that line is horizontal, which will change its color to black. And now I can put a coincidence point in one of the circles and align it to the line, which is aligned to the overall part. Now everything is black. So now I can go through and start extruding the pegs. So I'll grab each of the pegs and pull them up. And this was a goof up. I didn't actually grab each of them, so I can hop back into the feature, make sure that I grab the rest of the pegs, and pull them up into 3-dimensional space. And we can see that it lines up really nicely with the inside of the ring diameter. So now let's hop back in and draw the standoffs for the ring itself, so that it's able to sit up from the base of it. So I'm just going to draw a 45-degree angle for the outer part of the arm and mirror that so that I get a nice V shape. And then I'll draw another 45-degree angle for the inner part of the arm. Get that dimensioned out. And then I'll go ahead and mirror that as well. And then these arms, I know I want to pattern around the same circle that I did for the initial pressure peg. So I'll grab each of the sides of the arms, I'll select the center point, I'll make the quantity 4, and they'll match up exactly with the previous circle diameters. So now in a new feature, I can go through and extrude these parts out. And this is where I put the ring flush against the base, but really I want it to stand off just a little bit. So I'll go ahead and pull it up, make sure that I have enough room. I mean, I have to go ahead and pull the trinket up because really I want the NeoPixel ring to be just slightly above the trinket so that the trinket has room for its JST connector, but then the NeoPixel ring isn't potentially going to hit the corners of the trinket. So I went through one of the things that I've learned from dealing with Fusion 360 is kind of what the capture position tool does, and really it does just what it says. It captures the position of all the parts at any given time. I had an incorrect assumption for a while that the capture position captured it for whatever part that you're actively working on, but really it just captures the position of all the parts at a given time. So I needed to go through here and reorder those captures. I really could probably just remove one and make sure that everything is positioned the way I wanted to, but I felt like leaving this in because it shows a nice example of manipulating the timeline to get things positioned exactly where you want. So now I've got the trinket space just slightly above the base. I've got the ring position slightly above the trinket, and now I can extrude those pegs out to the bottom of the ring base and then offset them so that they're slightly above the ring, which means that they'll be able to hold the NeoPixel ring in place. So that's looking good. And now from here, the next thing I want to do is pull up those standoffs. So I'll go ahead and grab all the pieces of the standoff. so that I can start pulling those up with the extrusion. So something to point out as I'm going through here, Fusion 360 is really great on allowing you to select pieces to interact with through other pieces as long as you have the select through feature turned on in the select box. So I'll go ahead and pull these up a little bit and then switch over to two objects so I can pull the standoffs to the bottom of the NeoPixel ring. So now with those pulled up, we'll go ahead and hit OK and check out what we've got. So move everything out of the way, and these are looking pretty good. We'll have to do a test print of this to make sure that they line up, but I'm happy with the standoffs here. So now we'll go through and start moving the trinket into place. So there's a little bit of a goof up here that I kind of mentioned earlier as far as how capture position works, and I didn't totally get this until just now. So I've got those two capture position features next to each other. I thought that they applied to a body part specifically, so I went to the first one and moved this trinket. Once I finish the capture, the whole thing doesn't quite end up where I want. So whenever I go back to the first capture position, it looks good. When I go back to the second one, it looks it's back to the place it was before, and that's because the second one captured the trinket already moved. So I'll go ahead into the second one, move the trinket to the 45-degree angle, and now everything's good. And really, I could probably just delete the first capture position feature and leave it as is, but for now I'm just going to leave it in. So I'm moving it, I'm moving the trinket over just a little bit to kind of align it a little bit better in the middle of the NeoPixel ring. So now that that is moved over, that position is captured, I'll put up the ring, and it looks like the spacing is really good. So from here, I'll go ahead and create a new sketch, and these screw holes are positioned exactly the way that the diagram from Adafruit is drawn, using the same measurements, the same way we did with the NeoPixel ring. I just did this before. So I'm just going to project the hole positions onto my sketch. So now that I have these, I'm going to expand that hole, the screw hole out so that I have a wall to actually screw in. This is a point where I'm putting a wall, and after I print it out, if the screws are fitting too tight or if they're not fitting tight enough, I may come back here and put a tolerance on the inside of the mount. But for now, I'm just going to go ahead and put a 2mm wall on each of these. So I'll come in, grab the equal constraint, go to my first one that's dimensioned, and then make sure that each of the wall diameters match. So if I come back in here and change the wall diameter to something other than 2, all of the walls will change at the same time. So let's go ahead and extrude these up to the bottom of the trinket. And remember that I position the trinket so that it is aligned with the bottom of the mount and then offset up by a millimeter. So whenever we pull these up, the standoffs up, they will meet up with the bottom of the trinket, and when we print it out, theoretically they will meet up with the bottom of the trinket and give us enough space for our JST connector. So here's where I had already gone through and create a parameter for the wall size, but if you notice while I was going through and designing it, I didn't actually use that parameter. So I'll come back in, edit the sketch, and replace that 2mm with the parameter. And now, whenever I go through, because I use that equal constraint, I can pop up the parameters, change the value, and then whenever I switch it back to 2, we'll see them all pop up to 2. So from here, the last thing that I'd want to do is to put a little chamfer around the screw mounts. Adding a chamfer to the bottom of those mounts will increase the surface area that the mounts are actually using to hold onto the bottom of the plate. In previous designs, I've not added that chamfer, and as soon as you start torquing the screw, sometimes the mount, especially if they stand this far off of the bottom, will actually just rip off of the bottom. So we'll add a couple of chamfers here. I'm just going to add an arbitrary 1mm one. you'll notice that one of them overlaps just a little bit with the ring standoff peg, but I'm not too worried about that now since we're 3D printing. So now we can go ahead and hide all of our pieces and then start playing on sending this out to a 3D printer. So I'll hit make, I'll select the body that I want to export out to STL and save this to my working folder. So I've already done a couple of these, so I'm just going to overwrite the previous one. So I'll just name it Testo1, and then we'll switch over to Slicer, which is the slicing software that I've been using. There's a Prusa specific edition, so it's tuned to the printer that I'm using. So I'll bring in the model. I will rotate it on the x-axis to get it flat with the bed, and then we'll go through and take a look at the settings that we want to print this with. So the first thing I'll do is I'll go ahead and slice the model and switch over to layer view so I can get an idea of some of the stuff I want to change. And then I'll go through, I'm going to drop the infill on this one since it's a test part. We don't actually need to fill it in much at all. And change some of the patterns just because I like how some of the infills and the bottom patterns work. I'm going to print it at a slower speed so that the first layer adheres well. Then all the rest of these settings look good. So let's resize it and take a look at it. So now we could step through the layers, check to make sure that the infill looks the way that we want, that there's nothing funny about the various layers that get printed, and it looks good. So let's export the G code and send it to the printer. So here's the first test print. All the standoffs and the pegs came out looking really good. So now I'm gonna go ahead and throw on the soldered NeoPixel ring and trinket. When I first started this project, my plan or the NeoPixel ring was actually going to be flush with the bottom of the print, and only later did I decide that I wanted the ring raised above the trinket to account for this JST connector. So the wiring's going over the top, but I think before this project's over, I'm going to go through and rewire the rings so that the wires are coming up from the bottom so none of the LEDs are blocked. Back in Fusion, I'll go ahead and flip the body over and create a new sketch. I know that the diameter of the dome is 60 millimeters, so I will draw out an octagon and give it a radius of half that. Now I want to nail down the octagon so that we get rid of those blue lines, so I'll draw a construction line and then make that line horizontal, which will nail down the octagon and give us those black lines. So now we can extrude it and extrude it up to the top of the base so that if we ever change the height of that base body, the octagon will come with it. So let's send it out to the slicing software and flip over to Slicer and then blow away the old model. So I'm blowing it away so that we can keep all of our old settings. So we'll align it, center it, and slice it and take a look at the layers. We'll switch over to preview and just slide it up and down, get an idea of what the print's going to look like, and send it to the printer.
How you like that thing? You like that thing? How you like that thing? How you like that thing? You like that thing? You like that thing?
I wasn't wild about how the standoffs were positioned and how the pistol was positioned. There were just a bunch of little things about this design that made me want to start from scratch. There were also some fumbles in Fusion 360 that I made that rather than living with sins of the past, I decided to start from the beginning and try it again. And I think with this starting point, it will work. So that's it. Hopefully you found this helpful. Hopefully future me finds this helpful and wants to continue making future videos. I know that there are a bunch of projects that I already have some footage for that I definitely want to put together and host up there for you to see. But for now, I will call it a day and see you later.